In this video, we'll be covering the third type of the application of calculus, which is rate of change. In the previous two videos, in the first video, we covered how to calculate the maximum and minimum problems. I showed you the core fundamental to use in every question, the minimum and maximum. The second video, we did calculus in motion, and I showed you the important hacks on distance, velocity, and acceleration. Now, just closing it up with rate of change, which is, I think, one of the simplest, because once you understand what they mean by rate, just the first derivative, and that's all you need to know and understand. But how they ask the question is the most important for you to understand as well. So let's attempt this question, and then I'll be throwing small nuggets of insight as I go along. It says calculate the volume of the water in dam is governed by the equation. So we're giving the primary equation here, which is V, which is volume 2000 plus 500 times time t minus 1/8 times time squared, where V is the volume of thousands of cubic centimeters. So the unit is cubic meters cubed, and t is hours. So t is in hours starting at the beginning of the year. So beginning of the year time will be 0 because nothing has happened. It's the beginning, right? So this says calculate the volume of the water at the beginning of the first year. Okay, the beginning of the first year, the volume of the water. What's time in the beginning of the first year? Time will be equal to 0 because nothing has started. So we just substitute 0 where there's t, and then the volume at the beginning of the year will be 2000 cubic meters. That'll be the volume at the beginning of the year. Straightforward and straight to the point. And the next question is asking us calculate the rate at which the volume of the water is increasing at T3. So predominantly three things here. First is rate. Let's get that. What does rate mean? Rate means the first derivative. So let's rewrite this formula in terms of V of t, which is 2000 plus 500 t minus 1/8 t squared. I didn't change anything. I'm just writing it in terms of t. I prefer that because it will be easy for me to say v prime of t in terms of t, so that you know we're deriving in terms of t. The constant will be 0, and then 500t will be 500, and then we drop the exponent of 2, which will be 1/8 times 2 t to the power of 2 minus 1. So v of t, the derivative is 500 minus 2 into 2 is 1, 2 into 4, 2 into 8 is 4, which is 1/4t. This will be our first derivative, t. Now we've calculated the rate, but they're telling us the rate after how many seconds? 3 seconds. So it means where there's t, we need to substitute 3. Let's go ahead and do that. Our rate is given by 500 minus 1/4 t. We're substituting 3 where there's t, which means it will be 500 minus 1/4, and we're going to substitute the value of 3 over there. So if you punch that into the calculator, you'll see that we're going to get 499.25. Remember, this is rate, meaning that it's cubic per hour, because our units are cubic meters and per hour. That will be the rate of which the volume of the water will be increasing when time is 3, after 3 hours, because time is in terms of hours. So let's go to the next question, which is question 3, which is how long will it take for the volume to start decreasing? So let's say decreasing, asking for really first derivative or the rate, but we already calculated that formula, which is primary x is equals to 500 minus 1/4 t. But now they're asking how long will it take to start decreasing? So how long? They're asking for time. How long will it start decreasing means that we have to equate this rate to 0. Or you can also look at it as a similar question when they're asking you maximum and minimum. You take the original equation, derive it once, and equate it to 0 and solve for t, which will be 1 over 4t is equals to negative 500. And then we divide both sides by negative 1 over 4. If we divide both sides by negative 1 over 4, you'll find that you are going to get 2,000 hours, which is a very long time. So that's how long you'll start to see the dam really decreasing. And the fourth question is asking us something very interesting. They're asking us how long will it take for the tank to be empty? The tank to be empty. What should happen for the tank to be empty? That's the question you need to be asking. For the tank to be empty means the volume is 0. So we'll take our original equation, 500t minus 1 over 8 t squared, and you're going to equate it to 0. Means we have 0, 2,500t minus 1 over 8 t squared. So therefore we can write this as 1 over 8 t squared minus 500t minus 2,000 is equals to 0. And we can just simply plug everything into our magic formula, which is our quadratic equation, minus b plus the square root of b squared minus 4ac or divided by 2a. And we should find that the t that we get when we calculate the positive t will be 4,004 hours. That's how long it will take the tank to be empty. And if you want to calculate how many days, you can divide this by 24. Then you want to calculate into months. After dividing it by 24, you can divide it by 30. Then you're going to get the months, and then so on and so forth. But in this context, they asked you how long does it take the tank to be empty. And in that way, we would have concluded our series in applications of calculus. So if you found value in this video, really hit the like button and really be kind to share it with your peer or friend. It's good to help other people and share the knowledge. And if you haven't checked out the previous 2 videos, they'll be uploaded as well. Go ahead and check it, relook it. If you have any questions, comments, please leave them in the comment. I'll hasten attend to them.